Greetings. The question reads, Figure 9.1 shows a solid cylinder of mass 200 kg immersed in water in a rectangular transparent tank. The cylinder has a cross-section area of 0.5 meter squared and the height of 80 centimeter. It is placed 40 centimeter below the water surface and it is held vertically in the position by two ropes. The rectangular tank has a height of 160 centimeters. So you can see this is the rectangular tank they are talking about. Okay. And the first question reads, the density of water is 100 kg per meter cubed and gravity is equal to 10 Newton per kg. State Archimedes principle. State Archimedes principle. Okay, so we have been told to state Archimedes principle. So Archimedes principle states that when an object is wholly or partially immersed in water, its upthrust is equal to the weight of the water displaced. I'm going to repeat in case of those who haven't heard. So Archimedes principle states that when an object is wholly or partially immersed in water, its upthrust is equal to the weight of the water displaced. Okay, so we have answered part A, and we have said that Archimedes principle states that when an object is wholly or partially immersed in water, its upthrust is equal to the weight of the water displaced. And question B reads, calculate the pressure due to the water at the top of the cylinder and at the bottom of the cylinder. So first question, we have been asked to calculate the pressure of water on the top of the cylinder. Okay, so this is the cylinder they are talking about, and they have told us to calculate the pressure which is on top of the cylinder, which is here. So in short, we're just calculating the pressure which is here. So if you see here, we have the height. We also have the density which is here. So you and I know that pressure is given by the formula pressure, or I'm just going to write it here. So pressure is given by the formula density multiplied by gravity multiplied by height. Density multiplied by gravity multiplied by height is the formula for pressure. So you correct your data here. We have data. So under data, do we have density? Yes, density we have been given here. We have density which is 100 kg per meter cubed. So I'm going to put D is equal to 100 of density which is 100. We also have gravity which is 10 Newton per kg. We have been told in this question. So gravity, our gravity is 10. And the height, so the height, I said that the height, it's from here up to here, because we are calculating pressure on the top of the cylinder. Calculating pressure on the top of the cylinder, and the distance is from here up to here. So we have a height which is 40 centimeters. So our h is equal to 40 centimeters. So if you see here, we have this height in centimeter, and we have gravity which is in meter cubed. So we can't find pressure using centimeter and meter cubed, because these are unlike things. They are not like. So we need to change this into meter cubed so that we find the correct pressure. If you just go direct, you'll be marked wrong. You can't compare this, you can't multiply this and this, because they are not the same. This one is centimeter, this one is in meter cubed. So you need to convert this into meters. Okay, so you and I know that 100 centimeter is equals to 1 meter, Okay, what of 40 centimeter? So 40 centimeter will give us x. Since we don't know, then we just cross multiply. So we're going to have 100 x is equals to 40. Then we just make x the subject of formula by dividing both sides by 100. So by 100, and by hundreds. Okay, so this and this will go, hence we're going to remain with x. X is equals to 40. 4 divided 10, it will give you 0.4 meter. Okay, so this is the height. Remember, when you have been given density in kg per meter cubed and the height in centimeter, you convert the that height from centimeter to meters. Okay, using this formula, 100 centimeter is equals to 1 meter. If you want, you can just go direct by dividing the centimeter given by 100. Okay, so we have our height, which is 0.4. We have found our height to be 0.4. Okay, so having written your data down here, you can now just replace in the formula, because you and I know that pressure is given by the formula density multiplied by gravity multiplied by h. So where there's h, you just put this height which we have found, and where there's gravity, you just put 10. Where there is a density, you put 100, which was given here on the question. So let's find pressure. So pressure is equal to where there's density, we put 100 multiplied by gravity, which is 10, multiplied by 0.4. So pressure is equal to, when you multiply 100 times 10 times 0.4, it will give you 400. It will give you 400, because 10 multiplied by 0.4, it will give you 4. Hence 4 multiplied by 100, which will give you 400. So remember, we are calculating pressure, and pressure, the SI unit for pressure are pascals. Okay, pascals. So SI units are very important in physics. Never should you write an answer without the SI units, unless if it's a ratio. Okay, so we have found the pressure on the top of the cylinder, which is 400 pascals. So here the pressure is 400 pascals. Okay, so we can write here. So we found 400 pascals. Okay, so we proceed to B2, and B2 wants us to calculate the pressure due to the water at the bottom of the cylinder. At the bottom of the cylinder, and the bottom of the cylinder, it's here. So they want us to calculate the pressure which is here, Remember, the one we are calculating is the pressure which is here, but here they want us to calculate the pressure which is at the bottom of the cylinder. Okay, so you should know your height here. You should know your height before you proceed. So from here up to here, that will be our height from here up to here, and you just add 40 plus 80. 40 plus 80, that will give you 120. So our h, so I'm going to write our h here. H is equals to 120 centimeter. 120 centimeter. Then you start your procedure. So we can find it here. Okay, so you know that pressure is equal to density times gravity times height. So pressure is equals to density. We have been told our density is here. We maintain the density which we were given. So 100 multiplied by gravity, it's 10 here, multiplied by height. But if you see how height, it's the height is in centimeter, so we need to convert that into meter, because we cannot multiply meter cubed and centimeter cubed. There's no math like that. So we convert 120 into centimeter. So just do what we did. 100 centimeter is equals to 1 meter. What over 120? And if you don't want to do that, as I said earlier, I said that you just divide the centimeter given by 100. So 120 divide 100, it will give you 1.2. So our height will be 1.2. So while there's h here, we just put 1.2. 1.2, then we multiply. So 100 multiplied by 10 multiplied by 1.2, it will give you 1200 pascals. Don't forget the units. Okay, so here 10 multiplied by 1.2, it will give you 12, and 12 multiplied by 100, it will give you 1200, which is here. Okay, so 1200 is the pressure on the bottom of the cylinder, which is here. So here we have 1200 pascals, 1200 pascals. Okay, so if you're watching this on YouTube, kindly subscribe, and if it's on TikTok, please follow and share, because sharing is caring. Okay, so we have part C here, which reads, calculate the force due to the water pressure exerted on the top of the cylinder. Calculate the force due to the water pressure exerted on the top of the cylinder and the bottom of the cylinder. Okay, so they want us to calculate the force that is exerted on the top of the cylinder. So remember, we found in the pressure here on the top of the cylinder. That was question B1, and we found pressure to be 400 pascals. So 400 pascals. So we have learned that pressure and force are related by this formula. Pressure and force are related by this force. So this is the ratio between, or this is the relationship between force and pressure. So you know that pressure is equals to force over area. Pressure is equals to force over area. This is the relationship between pressure and force. Okay, so let's start by calculating the force on the top of the cylinder, the pressure or the force on the top of the cylinder. So on the top of the cylinder, which is here, we found our pressure to be 400 pascals. You can see from here where we calculated the pressure due to water at the top of the cylinder, and we found it to be 400. So we're going to put 400 where there's P. 400 is equal to force. We don't know the force, that's what we are finding. Okay, over our area. We have been given the area here. If you remember well, here where it says the cylinder has a cross-section area of 0.5. So this is the area of the cylinder. This is the area of the cylinder. So this is pure physics, but if you're doing ordinary, you can attend this session so that you learn one or two things, because there is no difference between pure physics and ordinary physics. Okay, so I've read here that the cross-section area is 0.5. so this means that the area for this cylinder is 0.5. Okay, so 400 is equals to force. Where there is area here, we put 0.5. Okay, then we just cross multiply. So this can be also written as 400 over 1 as a fraction. So cross multiplication, I mean by this will multiply with this and this with this. So going 1 multiplied by F will remain with the force here is equal to 0.5 multiplied by 400. 0.5 multiplied by 400, it will give you 200. And remember, this is force, and force is calculated in Newton. So we're going to have 200 newtons. So this was the force that was exerted on top of the cylinder. So I have 200 Newton. Let's now find the force that was exerted on the bottom of the cylinder. The force that was exerted on the bottom of the cylinder. So on the bottom of the cylinder here, we found the pressure to be 1200. If you remember, we found the pressure to be 1200. And I am going to repeat what I said. I said that pressure and force are related by this formula. Pressure is equals to force over area. Pressure is equals to force over area. So we find the pressure to be 1200 on the bottom of the cylinder. So where there's pressure, we're just going to put 1200 is equal to force. We don't know the force, right? Hope this is not disturbing. We don't know the force over the area. We were given the area. We have the area which is 0.5. The cross-section area is 0.5 meter. So where there is a area, we're going to put 0.5. 0.5. Then we'll just multiply, cross multiply as usual. 0.5 multiplied by 1200. This will give you 600. Okay, this will give you 600. And so we're going to have force is equal to 600. As usual, you don't forget the SI units in physics. So force is measured in Newton. Okay, 600 Newton. So here is 600 Newton. So we have solved this question, which looked to be a bit of complicated. So I hope you have learned one or two things from what we have solved. So the total marks for this question is about 6 marks. Okay, so this is how you can get this kind of question. So remember to subscribe and follow so that you don't miss the next video I'll be dropping. I'll be dropping on TikTok and on YouTube. So we are a school of online lesson where we learn physics, mathematics, chemistry, additional mathematics, and many more subjects. So if you want to have more information about us, you can contact us on this WhatsApp line, +260 965 15 98 65. This is the WhatsApp line you can use to get in touch with us so that we learn together. Remember, alone you can try, but together we can do it. I greet you.